Useful energy. Energy is used every day to make our lives easier. Examples. Useful energy. Electrical energy is used for appliances like televisions, computers, radios, and almost every appliance in our homes. Chemical energy from fuel is used for cars. Heat energy is used in hairdryers and stoves. Kinetic energy is used in tools and machines like drills and cranes. Interesting facts. Every appliance has a label showing how much energy it uses per second. It is a number with a unit W. For example, a small heater is marked 2000 watt. This means it uses 2000 joules of energy every second. Wasted energy. Some of the energy transferred in a system can be lost to the environment. This energy is known as wasted energy. It is wasted in the form of heat and/or sound. Examples. Wasted energy. Energy is lost as sound in electrical drills, hairdryers, and food processors. Heat is a form of wasted energy in a candle, lamp, and engine. In generating electricity, almost 50% of the available energy in coal is wasted. The arrows in this diagram show how energy is transferred in a system. Every system begins with an input of energy. In both examples, the appliance receives electrical energy. This is shown as 100% because all the energy entering the appliance is electrical energy. The arrows then show what happens to that energy after the appliance starts working. Look at the electrical food processor. Its useful job is to make the blades turn so that it can chop, mix, or blend food. Turning movement is called kinetic energy. 70% of the electrical energy is changed into kinetic energy, so this is the useful energy transfer. However, the food processor also makes a noise and becomes slightly warm while it works. 30% of the electrical energy is transferred as sound and thermal energy. This is called wasted energy because it does not help the food processor chop the food. Now look at the compact fluorescent lamp. The lamp also starts with 100% electrical energy. Its useful purpose is to produce light, so 80% of the electrical energy is transferred into light energy. The lamp also gives off some heat. 20% of its energy is transferred as thermal energy. The heat is not the main reason we use a lamp, so it is counted as wasted energy. It is important to notice that the energy is not destroyed. It is transferred into different forms. In each example, the useful energy and the wasted energy add up to 100%. For the food processor, 70% kinetic energy plus 30% sound and thermal energy equals 100%. For the lamp, 80% light energy plus 20% thermal energy also equals 100%. This helps us understand that appliances are more efficient when more of the input energy is transferred into the useful form of energy. Interesting facts. These diagrams with arrows representing energy inputs and outputs are called Sankey diagrams. Energy efficiency. Energy efficiency is determined by how much input energy is used to obtain useful output energy. The more input energy is used usefully, the more efficient the system. Remember that 65% effective means that only 65% of the input energy is available for the motor to work. The rest of the energy is wasted in the form of heat and sound. This diagram shows how energy is transferred in a motor using a Sankey diagram. The white arrow on the left represents the input energy, which is 100% chemical energy stored in fuel. As the fuel burns, the chemical energy is converted into different forms of energy. Only 65% of the input energy becomes useful kinetic energy, which is the energy that makes the motor move and do useful work. The remaining 35% of the energy is not useful for moving the motor. Instead, it is transferred to the surroundings as thermal, heat, energy, and sound energy, which are considered wasted energy. No machine is perfectly efficient, so some energy is always lost to the environment. The more useful energy a machine produces and the less wasted energy it releases, the more efficient the machine is. This is why the motor in the diagram is said to be 65% efficient. It converts 65% of the input energy into useful work while the other 35% is lost as heat and sound. Quick facts. The energy output of a system is always less than the energy input. The efficiency of a system is calculated by dividing the energy output by the energy input. This diagram shows how energy is transferred in a television. The television receives 600 J of electrical energy as the input energy. It then converts most of this energy into 400 J of light energy, which is the useful output energy because it allows us to see the pictures on the screen. However, not all of the electrical energy is converted into useful light. 100 J is transferred as thermal, heat, energy, and another 100 J is transferred as sound energy. The heat is considered wasted energy because it is not the main purpose of the television, while the sound can be useful when you are watching or listening to something. Altogether, the outputs still equal the input energy. 400 J plus 100 J plus 100 J equals 600 J, showing that energy cannot be created or destroyed, only transferred from one form to another. This diagram also demonstrates that a device usually produces more than one type of energy output, with some energy being useful and some being transferred to the surroundings. Paste Activity 5 and listen to the information. Question 1. The boiling pot on the stove uses heat energy usefully to cook or boil the food inside it. Some energy is wasted as sound, such as the bubbling water, and sometimes as light from the stoveplate or flame. Write the useful energy as heat energy for cooking and the wasted energy as sound energy and light energy. The vehicle in the picture uses chemical energy stored in fuel. Its useful energy is kinetic energy because the vehicle needs to move from one place to another. Not all of the fuel energy makes the car move. Some is wasted as heat from the engine and exhaust, as well as sound from the engine, tires, and traffic. Write kinetic energy under useful energy and heat and sound energy under wasted energy. The torch uses chemical energy from its batteries. The useful energy is light energy because the torch is used to help us see in dark places. A torch can also become a little warm, so some energy is wasted as heat energy. Write light energy as the useful energy and heat energy as the wasted energy. The electric drill uses electrical energy. Its useful energy is kinetic energy because the drill bit rotates and makes a hole in the material. The drill also makes a loud noise and may become warm while it is used. These are forms of wasted energy. Write kinetic energy under useful energy and sound and heat energy under wasted energy. The hairdryer uses electrical energy. Its useful energy is heat energy because it dries hair by warming the air, and kinetic energy because it blows the air towards the hair. It also makes a noise while it works, so sound energy is wasted. Write heat and kinetic energy as useful energy and sound energy as wasted energy. The candle uses chemical energy stored in the wax. Its useful energy is light energy because a candle is used to light an area. However, a candle also gives off a lot of heat energy. If the purpose is to provide light, the heat is wasted energy. Write light energy as useful energy and heat energy as wasted energy. The electric iron uses electrical energy. Its useful energy is heat energy because the hot sole plate removes wrinkles from clothing. The iron may also make a small sound and produce a little light from its indicator. These are not its main purpose, so they are wasted energy. Write heat energy as useful energy and sound and light energy as wasted energy. The electric kettle uses electrical energy. Its useful energy is heat energy because it heats the water for tea, coffee, or cooking. The kettle may make a clicking or boiling sound, so sound energy is wasted. Write heat energy as useful energy and sound energy as wasted energy. The food processor uses electrical energy. Its useful energy is kinetic energy because its blades spin to chop, mix, or blend food. It also makes a noise and can become warm while it works. Write kinetic energy as useful energy and sound and heat energy as wasted energy. The radiator or heater uses electrical energy to warm a room. Its useful energy is heat energy because heating the air is its purpose. It may make a small sound while it works, and some energy can be lost as light from an indicator. Write heat energy as useful energy and sound and light energy as wasted energy. Question 2. For this question, choose 3 different everyday objects that do not appear in the pictures above. Think about what each object is meant to do first, that is its useful energy. Then think about energy that is produced but does not help it do its main job, that is wasted energy. For example, you could choose a television, a washing machine, or a toaster, but do not repeat the pot, vehicle, torch, drill, hairdryer, candle, iron, kettle, food processor, or heater. Make sure you write the object in the first column, then its useful energy in the next column, and its wasted energy in the last column. Question 3. An electric drill is 85% efficient. This means that 85% of its total input energy is useful, and the remaining 15% is wasted. The drill uses 2,000 joules of energy. First, find the wasted percentage. 100% minus 85% equals 15%. Then calculate 15% of 2,000 joules. 15 times 2,000 equals 300. The answer for question 3.1 is that 300 joules of energy are wasted. For question 3.2, think about what happens when a drill works. The useful energy is kinetic energy because the drill bit turns. The wasted 300 joules are mainly transferred as sound energy and thermal energy. The drill makes a loud noise and can feel warm after being used. Write the summary that you find on the screen. This is the end of Unit 5.